Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about limits at infinity in calculus. So we're talking about limits that look something like this. Limit as x approaches infinity. Yes, the infinity is in the limit. And then you have some function here, like let's say x plus 2 divided by x squared minus 4x plus 12. And the secret is, once you know the rules and the shortcuts for limits at infinity, you can solve this problem very quickly. Now before I do my method, let me tell you the method they usually teach in school. The method they would tell you in school is to choose the highest degree, which is in this case x squared, and then they'd want you to multiply by a fraction, 1 over x squared and 1 over x squared. You would distribute this to every term in the numerator and the denominator, and if you do it correctly, you would end up with, again, limit as x approaches infinity, of numerator 1 over x plus 2 over x squared, in the denominator 1 minus 4 over x plus 12 over x squared. I'm assuming this part makes sense because this is pre-calculus, and for that reason I'm going to keep going with the explanation. The first thing you should know about limits at infinity is that when you have 1 over x or 1 over x squared or 1 over x to any power, if you put an infinity there in the denominator, any number divided by infinity is just going to equal 0. So in other words, 1 over x is going to become 0, 2 over x squared is going to become 0, 4 over x is going to become 0, and 12 over x squared is going to become 0. Meaning your final answer would just be 0 divided by 1, which is not undefined because that would be 0 in the denominator. The answer would just be 0. And this is the long way you do it. This is the way you might learn it in class. But what if I told you that I could get the answer 0 in less than 5 seconds? And it really is that simple. Let me explain. Whenever you have a limit at infinity question, there's only 3 results that can happen. It's either the degree of the numerator is higher, the degree of the denominator is higher, or the degrees are equal. This is the only 3 results you could possibly have. And the good news is, the answer is the same every time depending on which of these 3 you have. If the degree of the numerator is higher, then the answer is always going to be dne, does not exist. Now technically the answer could be infinity or negative infinity, but that's a little advanced for this video, so I'm not going to talk about that. Just write dne. If the degree of the denominator is higher, then the answer is always 0, no matter what. That's what happened in the last problem, because look at the original problem again. X squared, the denominator has the highest degree, which means the answer is automatically 0. Again, in less than 5 seconds, you know that. And then the last case we have, and this is really the only tough one, is when the degrees are equal. So what I like to say for this, I like to say divide the leading coefficients. And now I need to explain what I mean by that. So for instance, if the problem is limit as x approaches infinity of 2x to the 4th plus 12x squared divided by negative 5x to the 4th plus 8. The first thing you can notice is that the plus 8 and the plus 12x squared is not even going to matter for this problem. The only thing that matters is the x to the 4th terms, the highest degrees. And when I say divide the leading coefficients, I'm talking about this 2 and this negative 5 here. And you can say the answer is immediately 2 divided by negative 5 or negative 2/5. And that's basically it. Now there are a few complicated scenarios with this. Like for instance, what if I said limit as x approaches negative infinity of 3x squared minus 5x plus 6 divided by 2x minus 8. As you can see here, the highest degree is the x squared, but will our answer change if it's negative infinity? And the short answer is no, the answer will not change, because we know in this case that since the numerator is higher, the answer is dne, and that's our final answer. And even if this was, for instance, a 2x squared in the denominator, then the answer would not switch from 3 halves to negative 3 halves. The answer would still be 3 halves, even though it's negative infinity. The negative infinity really doesn't matter unless your teacher or professor want you, instead of writing d and e, they want you to write infinity or negative infinity. This actually would matter, and what you would do here, first let me get rid of the squared to bring us back to the original problem again. What I would recommend doing is plugging in the negative infinity just into the leading terms, so that we would have 3 times negative infinity squared divided by 2 times negative infinity. A negative number squared becomes positive, so it's 3 infinity squared divided by negative 2 infinity. One of the infinities cancel, leaving you with negative 3 halves infinity, or you can put the infinity in the numerator because it's the same thing. And since 3 halves times infinity is still infinity, then the answer is negative infinity. Final answer for that one. Again, this is pretty advanced. If you don't understand it, it doesn't matter. If you just wrote d and e from the beginning, we would be fine most of the time. Now here's another case that might throw you for a loop. What if I have limit as x approaches infinity of numerator x plus 1 times x minus 5, and in the denominator we have x minus 3 times 4x plus 1. One thing you can do is you can FOIL this, but honestly it's unnecessary. And the reason why you'd FOIL is because if you FOIL it, then you get numerator x squared minus 4x minus 5 divided by the denominator 4x squared minus 11x minus 3. And now you know the answer's going to be 1/4 because the degrees are equal. And I'm just looking at the invisible 1 in front of the x squared and the 4 in the denominator, and that gets me 1/4. And you can do that. You can do this FOILing method. But the method I want you to use is I really just want you to FOIL the first terms because that's the only ones that matter. In other words, multiply this x with that x, and then multiply this x with that 4x. Because then you'll just get x squared divided by 4x squared. And as we know, the rest of the terms are not going to matter. Only the leading degrees matter. And you get 1/4 a whole lot faster. And that's what I recommend for problems like this. And then the last special case you can have is you can have something crazy like this, limit as x approaches infinity of the inverse tangent of x. There's a few of these trig ones you should probably have memorized. This is definitely one of them. This limit is just going to be pi over 2. I recommend memorizing it. And if we went the other way to negative infinity for the same function, inverse tangent, then that is going to be negative pi over 2. And again, I recommend just memorizing that result as well. Other common trig functions you'll see, it's pretty much just sine and cosine. If you have limit as x approaches infinity of sine x, this is just going to be d n e all day, every day. It's impossible. The sine function never settles on one value is the technical reason, so we say d n e. And it's true if you do x approaches negative infinity, and it's also true if we did cosine x. Cosine does not settle on a single number, so we'd say d n e does not exist for that one as well. But if you have something interesting like this, sine x divided by x, well, this is a very famous problem. It's called the squeeze theorem or the sandwich theorem, which I'll probably cover in a different video. But the answer ends up being 0 because of the squeeze theorem or the sandwich theorem. So that's going to do it for this video. Thank you all for watching. My name is Dan the Tutor, and I hope you have a great rest of your day. Take care, and bye-bye.